Shri Krishna educational channel. Please like, share and subscribe my channel. In this video I am going to explain about the chemical properties of alcohols from class 12th alcohols, phenols, ethers chapter. So here the first the chemical properties of alcohols. When the alcohols which can act as both nucleophiles as well as the electrophiles. Alcohols consisting the oxygen has a two pair of electrons. These pair of electrons can donate to the electrophiles where the electron deficiency is there. There it can donate to form the corresponding the compounds of oxonium ion. Later it can lose the proton and forms the ethers. Okay, similarly it can also act as a electrophile when the alcohol which is treating with proton and forms the oxonium ion. Now this oxonium ion, okay, when it is treating with the strong nucleophile like bromide ion. So when this bromide ion attacks on the oxonium ion consisting carbon, so that case the water molecule can be leaved out and the nucleophile Br minus which can be attached to this carbon, and in addition to that water molecule can be obtained. So both the nucleophile as well as electrophile can be obtained by the alcohol. It can be act as both the electrophile as well as the nucleophile. Next, in the case of this alcohol which is mainly involved, there are two types of reactions. One is the cleavage of OH bond, other one is the cleavage of CO bond. So here we can discuss the cleavage of OH bond first. So in this case the reaction with the active metals, when the alcohols are treating with the metals like sodium, magnesium, aluminum, okay, these cases which can be gives the corresponding alkoxide of the metal. In addition to that hydrogen gas can be obtained. So here when the alcohol is treating with the sodium metal, it gives sodium alkoxide. In addition to that hydrogen gas. Similarly when the tertiary butyl alcohol which is treating with the aluminum metal, it gives aluminum tertiary butoxide. In addition to this hydrogen gas. Similarly when the ethanol is treating with the magnesium metal, it gives magnesium ethoxide and hydrogen gas, okay, which shows the similar properties like acid. So the alcohols have acidic nature. When the alcohol is treating with the strong base like sodium hydroxide or potassium hydroxide, that case it can gives the proton to the base and form alkoxide ion as a conjugate base, and the hydrogen can be taken by the base to form the conjugate acid. So the alcohol it can be acts as the acid as well as the base. Okay, when the alkoxide ion which is treating with the acid like water, so when comparing with the water, alcohol has less acidic nature, so that cases which can be acts as a base. So that case we can obtain the conjugate acid. Okay, in addition to that hydroxide ion as a conjugate base. Now among the primary, secondary, tertiary alcohols, the acidity order, if we see the primary alcohols which has more acidic nature than secondary alcohol than the tertiary alcohols. Primary alcohols has more acidic nature, that is due to the only one electron donating towards this alcohol consisting carbon. In case of the secondary alcohol, the two alkyl groups are present. Tertiary alcohol, three alkyl groups are present. So if the number of alkyl groups are present, so the cleavage of OH bond which is difficult. So as a result the acidity that should become decreases. So among the primary, secondary, tertiary alcohols, primary alcohols are more acidic nature. Next, the reaction with acids. In case of this alcohol, when those are treating with the carboxylic acid to form esters, this reaction is known as esterification. Okay, this reaction carried out in presence of the mineral acid. For example, when the alcohol ROH which is treating with RCOOH carboxylic acid, that case it gives ester as RCOO or in addition to that water. Okay, for this case when the methanol is treating with the benzoic acid in presence of the mineral acid, that case it gives methyl benzoate and water. When the ethanol is treating with acetic acid, it forms CH3COO C2H5. It is ethyl ethanoate and water. So this reaction is the esterification reaction. Next, when the alcohols undergoes oxidation in the presence of strong oxidizing reagent like potassium permanganate, potassium dichromate, sodium dichromate, H2CrO4, that case it gives the aldehydes, carboxylic acid as well as the ketones, okay, depending on the alcohol. When the primary alcohol which is undergoes oxidation in the presence of sodium dichromate and concentrated sulfuric acid, initially it gives the aldehyde. Okay, now the aldehyde further undergoes oxidation in presence of the sodium dichromate and concentrated sulfuric acid, it gives the carboxylic acid. When the butane 1-ol undergoes oxidation, it gives butanoic acid. Similarly, 2-methyl propane 1-ol which undergoes oxidation, it gives 2-methyl propanoic acid. So the primary alcohol which can also undergoes the oxidation in the presence of PCC, that is known as pyridinium chromochlorate, in the presence of dichloromethane, that case which will gives the aldehydes. And the butane 1-ol which is treating with the PCC in presence of dichloromethane, that case it gives the butanol. Similarly, 2-methyl propane 1-ol which is undergoes oxidation in presence of PCC, pyridinium chlorochromate, in the presence of the dichloromethane, it gives the 2-methyl butanol. 2-methyl butanol can be obtained. So in addition to that PCC, we can also take CrO3. So that case also we can get the same kind of products. And the secondary alcohols which undergoes oxidation in presence of these sodium dichromate, potassium dichromate or the potassium permanganate. So that case it gives the ketones. Secondary alcohols gives the ketones. The propane 2-ol which is undergoes oxidation in presence of sodium dichromate and concentrated sulfuric acid, it gives propanone, that is also known as the acetone. And the cyclohexanol which is undergoes oxidation, that case we can get cyclohexanone. In case of the tertiary alcohols which do not give any kind of oxidized product, even though when those are treating with the strong oxidizing reagent. And these alcohols which can undergo the dehydrogenation, okay, when those are passing on the copper metal at high temperature, that is 573 Kelvin. So here the primary alcohols, those are passed on the copper metal at 573 Kelvin, it gives aldehyde. When the secondary alcohols passed on the copper metal at 573 Kelvin, that case it gives the ketones. And the tertiary alcohols, those are treating with the copper metal at 573 Kelvin, it gives alkene. Alkene can be obtained here. Next, another reaction, that is the dehydration of alcohols. So alcohols can be undergoes the beta elimination in presence of the strong dehydrating reagents like the concentrated sulfuric acid or H3PO4. In presence of the concentrated sulfuric acid or H3PO4, that case which will gives the corresponding alkenes. Alkenes can be obtained. Here either the 85% phosphoric acid can be used or concentrated sulfuric acid at the temperature range, that is 373 to 473 Kelvin. So this case the water molecule is removed, so that this reaction is known as dehydration reaction. When the ethanol is treating with the concentrated sulfuric acid and heated at 473 Kelvin, so that case we can obtain the ethene. It is a double bond between the two carbons. And the secondary and tertiary alcohols which will gives the dehydration reaction under mild conditions, okay, that case the concentration, okay, which is concentration as well as the temperature can be reduced, that case also which will gives the alkenes. Okay, when the secondary alcohols propane 2-ol which is treating with the 85% phosphoric acid at low temperature, that is 440 Kelvin, which will gives propene. Whereas the tertiary alcohols which is very less conditions which is required, very mild conditions, that is when the 2-methyl propane 2-ol, okay, which is treating with the phosphoric acid, that is 20% phosphoric acid at 358 Kelvin. So that case it gives 2-methyl propene. Now among the tertiary, secondary and primary, tertiary alcohols which are more easily undergoes the dehydration rather than the secondary and primary. This is the mechanism of the conversion of ethanol to ethene. So first step is the protonation. Okay, when the ethanol is treating with the proton H plus, okay, that case it can be forms the oxonium ion. So the oxygen of the ethanol, okay, which can be accept this proton by donating the pair of electron to the H plus, and the oxygen gets the positive charge. This is known as ethyl oxonium ion. So now during this reaction, the proton is added to this alcohol. So this is a very fast reaction. Next, this oxonium, ethyl oxonium ion, which is further undergoes a dehydration. That case it forms a carbocation. This is a slow reaction. So this is a rate determining reaction. During this case, the carbocation intermediate is formed. Now third step, this carbocation which can be eliminates one of the proton from the beta carbon. Okay, that case which will gives the alkene, and in addition to that the OH minus can H plus can be released out. Next, when the alcohols which undergoes reduction in presence of hydrogen iodide and red phosphorus, that case which will gives the alkanes. Okay, when the methanol which is undergoes the reduction in presence of the hydrogen iodide and red phosphorus, it gives methane. And the ethanol is treating with the hydrogen iodide in presence of red phosphorus followed by heating, it gives ethane. So during this case, alcohols can be undergoes reduction to give the corresponding hydrocarbons. Next, the cleavage between the CO bond. So the reaction of alcohol with hydrogen acids. Okay, when the alcohol which are treating with the hydrogen halides in presence of the anhydrous zinc chloride, okay, followed by heating, it will gives the haloalkanes. Here the HCl and zinc chloride, this together which is known as Lucas reagent. This Lucas reagent can be helpful to distinguish the primary, secondary and tertiary alcohols. So when the tertiary alcohols, okay, which can gives oil drop appear in a short time in case of the tertiary alcohol, whereas the secondary alcohol within a 5 minutes it gives a milkiness obtained in the case of secondary alcohols, and the primary alcohols it forms a clear solution. So this way we can distinguish the primary, secondary and tertiary alcohols. Next, the reaction of alcohols with phosphorus tribromide. When the primary and secondary alcohols which can be react with the phosphorus tribromide, that case it can form bromoalkanes. And the primary or secondary alcohol which are treating with the phosphorus tribromide, so that case it can be form the bromoalkane. Okay, in addition to that it can forms the phosphorus acid. When the ethanol is treating with PBr3, that case it forms bromoethane and gives the phosphorus acid. Okay, this is about the chemical reactions of alcohols. Thank you.